Hey everyone, so it's Mrs. Slauson again, and the idea is we have started this together as class hopefully, and there's going to be a we do column and a you do column. So there are a lot of problems here, and I made all of these problems because there's a lot of these on your test. So I definitely want to hit this part. The idea is, fill this out, and then you can have it in front of you when you take your chapter 3 test. So again, I realized we did some of these together. So I am going to start with number 1 in case anyone missed it or they want to rehear it. What you can do is just fast forward to get to the point where we left off, which I honestly don't know because I haven't seen you yet. So here we go. Number 1, we've got these 4 functions at the top, and we will be evaluating the functions. We do want to remember in this whole situation that if we do have to take the square root of a negative number, and we'll be taking the square root of -1, that we replace it with an I. That is a big thing to remember. So let's get started. K of 4, and there's some review in here as well, because chapter 1 retake is going to be happening. So I'm going to be putting 4 in here. So K of 4 means I go to K's function. I put 4 in there. So these are not parentheses. We will not distribute the 3. We will look in the bars and we're going to simplify what 4 plus 2 is, which is 6. And what is happening here is we're just going to take the absolute value of 6, which is still 6. Remember, when you take the absolute value of a number, whatever's that final number in those bars, it comes out and it becomes a positive number. So when I'm done, I get 18. So I'm just going to write 18 up here because 3 times 6 is 18. So the idea is now you do this one. All right, number 2, K of -4, same function. Let's just put -4 in there. So again, don't distribute. These bars are parentheses bars. I'll simplify my number in there. I get -2. And again, whenever you get your absolute value bars to one number, the number that comes out will always be positive. And when, whoops, sorry, you couldn't see that. And when you do that, you get 6. So I'm just going to write a 6 up here. Let's move on to a different function now. We're going to work with F. So F says I should go here, and I'm just going to put 125 in there. And again, 125, hopefully you know your perfect cube roots. 125 is one of them. So the cube root of 125 is 5. So if you're like, I don't know my cube roots, then just type it into your calculator. Press math, scroll down to the 4th option, get your cube root, put 125 in. It's okay. So again, you do the one on the right. Let's go to h of -2. So this time I'm going to a whole different function. I'm going to this one. So writing it in here. So anytime you take a number to an exponent to a power, I'm going to highly suggest you put that number in parentheses. Now, as far as what do I do first here, I've got multiplying, I've got an exponent, and I've got subtraction. You always do the exponent first. And -2 squared means -2 times -2, which is 4. And if you don't type it into your calculator correctly, it will give you -4. So after that, I multiply, which is 8. And once I'm done subtracting, I get 3. So I'm just going to put 3 up here for my final answer. And you'll do the next one. All right, G of 5. So let's go up to G's function. I'm going to put a 5 in there. If I just add those up, I get 9, and the square root of 9 is 3, and I'll just be putting the 3 there. So hopefully this isn't too bad. Let's go to the same function, and this time let's put -13 in there. So -13 plus 4, well, that's a -9. Sorry, and then when I take the square root of that, well, we can't do that, right? But now we can because we've got this imaginary number. So what I'm going to do is break this down into the square root of 9 and the square root of -1. And now I can take the square root of 9, no problem, that's a 3, and I can take the square root of -1, which is an I. So that answer is 3i. It's an imaginary answer. Let's put -28 in. So same function. I don't have to go back up. So this time when I add them, I get -24. So last chapter, we would have said, nope, can't do it, but this chapter we can. So what I'm going to do is break it down right now into the square root of 24 and the square root of -1. And then if you remember, even though 24 isn't perfect, I could run my factor program and see that I could break it down into these factors. and then here comes the square root of -1. So this turns into 2, this stays the square root of 6, and this becomes I. 2 square root of 6i. What's the best way to write it? 2i square root of 6. They always like that square root, that check mark last. So you are also doing the problems on the right, just as you know. So, all right, number 8. Okay, so functions are at the top. This time we're going to go to h, and we're going to put x plus 1 in there. So normally it's x that's being squared. Now it's going to be x plus 1 that's being squared. And this is right from the Chapter 2 test. Not this exact problem, but very similar. So the square just means I have 2 of those x plus 1s. And this is a lot of neighbors meet the neighbors. So 1, 2, 3 neighbors, only two neighbors can meet at the same time. So I always start with the parentheses. And I am going to speed this up. I'm going to get x squared. Then I'm going to get 1x. And then I'm going to get another 1x, which becomes 2x. And then I'm going to take 1 times 1. I'm not going to add them. And I'm going to get 1. So those neighbors have met. And now this group still has to meet 2. So now 2 is going to meet everybody. And we're going to get 2x squared. We're going to get 4x. We're going to get the 2. And then I'm going to not forget about the subtracting 5. And then I can clean this up just even more by combining these like terms. So when I'm done, my final answer is 2x squared plus 4x minus 3. All right, so again, now you're going to do this one. Let's go to this one. So now we're back to composite functions. So we're going to start. So we have 2 functions, and sorry, I'm going to make these outer parentheses stand out a little bit more. And what I want to do is focus on what's in those parentheses. So I want to start with f of 8. So I'm going to go to f's function right here, and I'm going to put an 8 in it. So I'm totally ignoring the g right now. Well, cubed root of 8, that's a nice number. It's 2. So f of 8, once we're done, is worth 2. So I'm going to replace f of 8 with this 2, bring the g back, and now this says go to g's function right up here and put 2 in. And when I'm done, that's the square root of 6. And the square root of 6, you know, it's not perfect, and there are no factors that are perfect, so I'm just going to leave it like that. Square root of 6 is my answer to all of that. And then you'll do the one on the right. So now we got another composite function, but we're actually going to take the whole function and put it in the other one. So again, I always like to make those outer parentheses just a little bigger. And g of x, which is this, is going to go in there. All right, this says go to h's function and put all of this in there. So all of this, you know, imagine I'm drawing this long line, goes right there where that x is. So normally where x is going to be squared, all of this is going to be squared. So I still have the 2, and in for x goes all of this. So since there's quite a bit, I want to put it in parentheses. Instead of x being squared, now all of this is going to be squared, and then the minus 5. And now I want to clean this up. And this is kind of similar to that stuff that we did when we were working with inverses. What will happen is, you know, I can't do anything in the parentheses as far as order of operations go. But after parentheses go the exponents, and this squared is actually going to cancel out this whole square root. So I'm just left with x plus 4. I still have the 2 and the minus 5, so I'm just going to distribute now 2x plus 8, take away 5, and when I'm done, I can get 2x, combine those like terms for 3. So I'll put that answer right up there. Oh, I'm sorry you couldn't see that. I wasn't paying attention. So again, I just combined those like terms for the 3, and then I wrote my answer up there. So let's talk about the next problem. So I want you to notice that 10 is going to be very similar to 11. Same thing over here. So you have 2 options. You know, this just says take that composite function that you just worked with and put 2 into it. So since my composite function was left with 2x plus 3, One way I could do this is just go to 2x plus 3 and put the 2 in there. And that's actually probably the easiest way to do this problem. I'll multiply first, and then when I'm done, I get 7. So that's one way to do it. The other way to do it is to do this in pieces like we did up here. So just to point out. So for instance, if I make those bigger parentheses, and you know, sometimes this way is going to be easier, and sometimes this way, like what I did up here, is going to be easier. So I guess you'll kind of just have to decide what's going to work best for you. I tend to go and use both methods. So this says go to G's function and put 2 in. So okay, I can put 2 in here. And when I do that, I get the square root of 6. Well, the square root of 6 doesn't do me any good because it's not a nice number. So, Well, as it turns out, this g of 2 is worth the square root of 6. So now I'm going to replace g of 6 with that. G of 2, I'm sorry, with this. And now this says go to h's function and put the square root of 6 in there. So I'm going to run out of room, but let's put it over here. So normally where x is going to be squared, the square root of 6 is going to be squared. So 2, and here's the square root of 6, and this whole thing should be squared. And then I still have the minus 5. So again, you know, when I look at my order of operations to simplify this, nothing's going to happen in the parentheses. So after parentheses comes exponents, and that squared will cancel out the square roots, so we're just left with 6. And then I have the 2, and then I can multiply for 12, subtract 5, and still get 7. So which way was easier? Definitely this way on this problem. So when I'm done, there's my answer. Final problem, f of negative 8, g of 12. So this says we're going to be making a fraction, and I'm going to go to f's function and put a negative 8 in. Here we go. And then in my denominator, I want to go to g's function and put 12 in. So when I'm done, I get negative 2, because the cubed root of 8 is negative 2. 12 plus 4, that's 16. And when I take the square root of 16, that's 4. And then I can actually simplify this fraction and get negative 1/2. So what you're going to be doing is finishing the other side, and then you're going to submit the whole thing to OneNote. And that's it. I will see you on Thursday.